such solutions already in the field. So, for instance, we have advanced process controls in numerous pulp mills across the globe already. That works quite well in the pulp mill for adjustment of kappa, for instance, and other fiber properties. There are some examples, and I'll show you a couple of them in a little bit, where you can closely control strength parameters for packaging papers. The third one might seem a little odd here, the crunchiness of chips, but I put that in here because the challenge is for some branches of the food industry who are using advanced process control, pretty high-tech stuff, are very similar to the paper industry, using a new renewable natural raw material which changes with season and which farmer you got your potatoes from, in this case potato chips. But the customer who buys the potato chips wants them to look the same, to taste the same, and to have the same crunchiness every time he buys a bag. And one of the largest chip supplier in the US uses pretty cutting-edge advanced process control to get there. So it's being used in other industries already. The holy grail of closely controlled complex process parameters like cost of production, of course, is the money part. To my knowledge, nobody does that yet. Closely control quality and the cost in real time. You do this more on a daily, maybe monthly basis, like on, we should change this supplier, use more of this chemical, substitute energy with fiber or chemicals. But in real time, that's not being done as far as I know. I'm going to, the next couple of slides I'm going through a little faster. This one, I don't really need to explain the details to you. You're all paper makers. The outcome, the quality outcome of the finished paper, whether that's test liner or fluting or label paper or folded boxboard, depends on a lot of parameters. The fiber blend you're using, how much refining energy you're putting in there, what kind of additives you're using, how you manage your charge, and so forth. That's only the white boxes, or the white bubbles here, show only the stuff you actually measure, or can measure in a process. The gray ones are kind of hidden influence factors. Often you don't really know that you have a faulty signal coming from one of your sensors, or that your sensor just flatlined or just broke and the DCS just holds the last value. Operator interface, human error can be there. Seasonal variation, of course, I mentioned it in the potato example. So a lot of influence factors affect your final product properties. This one you've probably seen from a lot of vendors. I won't spend much time to it, just a reminder. So in a lot of your parameters, in particular, if you're talking about quality here, you see a lot of fluctuations. Because if you can't control it, you tend to err on the safe side, meaning all of this above the reject limit, that's basically wasted resources. You're either using too much fibers, too much energy, too much additives, whatnot. So first step is to visualize it. If it's a signal like, for instance, burst or compression strength, that's not an online signal that comes out of your lab, but you can make it a real-time signal. Then you stabilize it, and the real money comes in, then you're shifting it to where it actually needs to be. I don't need to have something up here sometimes. I need to consistently be down here. That's good enough. That's all my specification requires. I don't need to have the peaks above it. And that's where the real money comes in, either in energy or additives, fiber, whatnot. In order to get there, if you're talking about a high-level process solution, you're here on the level 3, advanced process control. And it it's not, I'm not talking about one type of solution here, a particular platform. It's the complexity of an optimization project. That's what I mean with that. So Max Suites happens to be our platform, but there's others as well. And this, what I'm saying here is valid for everybody. What you quite often is being overlooked, that if you want to get here, the two levels beneath it need to be in tip-top shape. They really you need to have all the instrumentation and the regular control loops. A big machine typically has well installed, maintained, calibrated, checked if the signal is actually real, and so forth. You need to have a certain amount of data management and visualization tools, predictive modeling, things like that. Predictive modeling I intentionally mention in level 2 here because it doesn't control anything. It just gives you an additional insight into your process. Of course, it's a foundation to get there, but anyway. So that's the technical part. I'm a process engineer. I typically tend to get lost in the technical details, so to speak, but I spoke about lessons learned. A very important portion of making this all work as a successful project is the people in an organization. The way a complex optimization process is set up in your mill. And I'm not talking about the project engineer or corporate engineering or the mill manager. I'm talking down to the operators. The operators need to understand it. They need to know how to troubleshoot it. They need to know what the potential things to look out for. They need to like it. It comes down to that. If your operators don't like it, they will make it fail. We've seen that many, many, many times, not just with our systems, but also with other complex process optimizations. So don't underestimate the people. As a matter of fact, I would go so far as it's 80% people, and what technology platform and what measurements you have, that's almost secondary. You can go to, my colleagues probably won't like it when I say that, but you can go to many different vendors for this kind of stuff. It comes down to how you execute it, how you plan it, how you execute it, and how you deal with that project after it started up and the performance guarantee is met. That's really the kicker. Another thing I'd like to, our company, as you probably very well know, is very heavy on consistency measurement. And so I share a little bit tidbit with you there. For packaging grades, 95 to 98% of what you reel up on the reel is fiber. So it's very important to have very good control of your fiber mass flow through the process, in particular consistency measurements. Flow meters are relatively easy to calibrate, and they don't tend to drift much. Consistency measurements, a little bit different story. There's different technologies and so forth. In a nutshell, what we're trying to accomplish here is from the fiber source, either the HD tower or the pulper, to the head box, you want to get from this kind of variation to almost flat, to be very stable, to be able to dose refining energy and all the additives. We just heard 2 papers about additives, accurately to target. So that's also not new, but what might be new is we do a lot of consistency measurement surveys. This is kind of the hallmarks of a healthy consistency control. It runs on automatic. A lot of it seems like trivial, but you'd be surprised. Control valve has room to move. Calibration is done properly. You have enough dilution water in that position. Sometimes you'll be surprised what you see there. And of course the valve is responding properly. The average out of almost 150 surveys we did in the last few years is only 30% of all consistency control loops we surveyed, which is well over 1,000. are actually considered healthy by this list. 70% violate at least one of these parameters. So if that's the case, a higher level process control will have problems to work properly. A few quick case studies. This is one out of the US, kraftliner, virgin fiber. In the US, kraftliner is sold by lineage or area, effectively, not by tonnage. So if you can deliver the same strength with less basis weight, that's where the money was in this particular thing. So basically we're modeling the stiffy, which is SETCD in this case, and what ended up happening, we basically replaced some of the fiber, other than we stabilized it, we replaced some of the fiber with jet wire ratio, which was possible to turn the fiber a little bit and get more CD out of it. I'm going to rush through those now. I'm already over time again. Central Europe, testliner, 100% recycled fiber. Here in Europe, just like here, you're selling testliner by the ton. So basically, the option the US had was not, but the target here was to reduce starch consumption in the metered size press. Basically, every testliner line in Europe has a metered size press. We also use the jet wire ratio, but the main levers here was starch consistency and rod pressure, meaning the dosing of starch. And here was the savings. The important part here is we closely cooperated with those guys for over 4 years. They're currently rebuilding one of their machines and ordered the same setup also with us, and so they're like it. Here's another long-term case. Label paper. It's kind of on the fringe of packaging. Here the task was to replace fiber with ash. In label paper you also need opacity. So virgin ash was added without compromising the strength. And you see here we stabilized it a lot. We're able to do this target shift. ROI target in general for projects like this is less than 12 months. It needs to be back in less than 12 months. Of course, that requires that the system runs way longer than 12 months for you to actually get the benefit out of it. So my last points I'm making here, and then we can come to an end. Digital solutions in most cases are handled like capital expenditure projects. So you have a project budget, corporate and engineering, they kind of, we could do this here, blah, blah, blah. Then they talk to OEMs and relevant suppliers. And the mill gets involved very late of the production team in the mill, typically. And then also after the performance run, there's not much of a plan here. So that's a little tricky. What we recommend from an organizational setup is you have a mill person who is the digital solutions champion and who is basically involved with these projects from the very early on all the way to later on owning this solution and its performance and tracking it and doing countermeasures if it doesn't work. You should have a sustaining budget or a maintenance budget in your mill. And you should involve the operators in production, not all of them, but key operators in actually the speccing out of the project already very early on. So I'm not going through the list here, but basically what you want is you install a solution, then you get that bump you want, and not only you want to maintain it there, but you also want to go into continuous improvement, right? You want to build on that, and okay, what else can we do? We add this sensor and we get even more efficiency out of it. Something like that. Or we switch to a different chemistry and we do some adjustments here and hey, it works even better. So don't forget the people involved, all the stakeholders, whether it's suppliers or your own people when you execute these projects. That's my message.
In India, most of our mills are 100% zero discharge, and the conductivity levels are almost 30,000. So would it work up under those levels?
Hello. Yes, thank you very much for the question. We total chemical management, total process management. Once we introduce one product which is, can say, fixing the fines of the system, we need to adjust our dry line accordingly. We may need to change the speed for a couple of hours, or we need to shift the drying curve with that. It will be total collaborative approach, and definitely it will give advantages even at the higher conductivities. So the level what we get, that we need to try on the machine.
Okay, based on experience in Southeast Asia and even in China, that using this combination amphoteric restrength and GPAM, we saw the product is still running up to 8,000. I understand in India, liner board making, maybe the situation is tougher, but the same answer, until we don't try that one, we don't know actually how potential of this product. But I believe if you try at least to give some benefit, maybe it's not as high as the better or easier condition, but it still give benefit. Why this mill is choosing to replace silica? Just purely because of the cost for this mill. And they saw also the benefit actually to make the system is cleaner.
Okay, thank you. Second question is with Mr. How much it will be reduced?
Yes, it is possible to replace complete starch with the TVAM, GPAM. We will replace the part first, and up to what we can get the positive ROI, good results. But practically it is possible. We can replace 100% starch with these strength additives.
Thank you so much.
Thank you so much for the question. Case study that was for the multi-layer duplex board.
So, especially in BCTMP layer.
BCT.
I think factory trials may give you a better
discuss
idea.
offline on that.
With this, we conclude the presentation session, but technical session 2, as well as the question answer round. Now, we move towards the memento presentation as a token of our appreciation to our esteemed speaker. May I request? Now, I invite Dr. Preeti Lal. Next, I request Mr. Tejinder Bir Singh Chahal. Now, I request Michael von Grumbkow. Finally, as a token of appreciation for his leadership and guidance, I request President IPTA, Shri Pawan Khaitan, to kindly present a memento to our session chairman, Mr. Agatya Thangaraju. Let's give a big round of applause to Mr. Thangaraju and all our esteemed speakers. Now, I request President of IPTA, our session chairman, and all the esteemed speakers to kindly join us on the stage for the group photograph. Before we conclude, we extend our heartfelt thanks to Mr. Agatyan Thangaraju for his outstanding leadership as session chairman. With this, we conclude technical session 2. It has been a day full of learning, innovation and valuable takeaways. We'll connect for the gala dinner later this evening. Thank you all and see you soon.